Bismillahirrahmanirrahim. Chapter 1, Fundamentals of Chemistry. Introduction. The knowledge that provides understanding for this world and how it works. Its science, the branch of science which deals with the composition, structure, properties, and reaction of matter is called chemistry. It deals with every aspect of our life, the development of facilities in daily life. Imagine the role and importance of photochemical products, medicines and drugs, soap, detergents, paper, plastic, paints and pigment instead pesticides, which all are fruit of the efforts of chemists. The development of chemical industry has also generated toxic waste is contaminated water and polluted air around us. On the other hand, chemistry also provides knowledge and techniques to improve our health and environment and explore and to conserve the natural resources. In this chapter, we will study about different branches of chemistry, basic definitions, and concept of chemistry. Branches of chemistry. It is a fact that we live in the world of chemical. We all depend upon different living organisms which require water, oxygen, or carbon dioxide for the survival. Today, chemistry has a wide scope in all aspects of life and in serving the humanity day and night. Chemistry is divided into following main branches: physical chemistry, organic chemistry, inorganic chemistry, biochemistry, industrial chemistry, nuclear chemistry, environmental chemistry, and analytical chemistry. Physical chemistry. Physical chemistry is defined as the branch of chemistry that deals with the relationship between the composition and physical properties of matter, along with the change in them. The properties such as the structure of atoms, the formation of molecules, behavior of gases, liquids, and solids, and the study of the effect of temperature or radiation on matter are studied under this branch. Organic chemistry. Organic chemistry is the study of covalent compound of carbon and hydrogen, hydrocarbon, and their derivatives. Organic compounds occur naturally and are also synthesized in the labor- laboratories. Laboratories. Organic chemists determine the structure and properties of these naturally occurring as well as synthesized compounds. Scope of this branch covers petroleum, protochemicals, and pharmaceutical industries. Inorganic chemistry deals with the study of all elements and their compounds except those of compound of carbon and hydrogen, hydrocarbon, and their derivatives. It has application in every aspect of the chemical industry, such as glass, cement, ceramics, and metallurgy, extraction of metals for minerals. Biochemistry. It is a branch of chemistry in which we study the structure, composition, and chemical reaction of substance found in living organism. It covers all chemical processes taking place in living organisms, such as synthesis and metabolism of biomolecules like carbohydrates, protein, and fats. Biochemistry emerged as a separate discipline when scientists began to study how living things obtain energy from food to how the fundamental biological changes occur during a disease. Examples of applications of biochemistry are in the fields of medicine, food, science, and agriculture, etc. Industrial chemistry, the branch of chemistry that deals with the manufacturing of chemical compounds on commercial scale, is called industrial chemistry. It deals with the manufacturing of basic chemicals such as oxygen, chlorine, ammonia, caustic soda, Nitric acid and sulfur acid, these chemicals provide the raw material for many other industries such as fertilizers, soap, textiles, agriculture, products, paint, and papers, etc. Nuclear chemistry. Nuclear chemistry is the branch of chemistry. Nuclear chemistry is the branch of chemistry that deals with the radioactivity, nuclear processes, composition, and manufacturing of chemical compound on commercial scale is called industrial chemistry. Sorry. Nuclear chemistry. Nuclear chemistry is the branch of chemistry that deals with the radioactivity, nuclear processes, and properties. The main concern of this branch is with the atomic energy and its uses in daily life. It also includes the study of the chemical effects resulting from the observation of radiation within animal, plant, and other materials. It has vast applications in medicine, treatment, radiotherapy, preservation of food, and generation of electrical power through nuclear reactor, etc. Environmental chemistry. It is the branch of chemistry in which we study about component of the environment and the effect of human activities on the environment. Environmental chemistry is related to other branches like biology, geology, ecology, soil, and water. The knowledge of chemical processes taking place in environment is necessary for its improvement and protection against pollution. Analytical chemistry. Analytical chemistry is the branch of chemistry that deals with separation and analysis of a sample to identify its component. The separation is carried out period so qualitative and quantitative analysis. Qualitative analysis provides the identity of a substance, composition of chemical species. On the other hand, quantitative analysis determines the amount of each component present in the sample. Hence, is this branch. Different techniques and instruments used for analysis are studied. The scope of this branch covers food, water, environmental, and clinical analysis. Basic definitions. Matter. Matter is simply defined as anything that has mass and occupies space. Our bodies, as well as all the things around us are example of matter. In chemistry, we study all types of matters that can exist in any of three physical states: solid, liquid, or gas. A piece of matter in pure form is termed as a substance. Every substance has a fixed composition and specific properties or characteristics. Where words in pure matter is called a mixture, which can be homogeneous or heterogeneous in its composition. We know that every substance has physical as well as chemical properties. The properties that are associated with the physical state of the substance are called physical properties like color, smell, taste, hardness, shape of crystal, solubility, melting or boiling point, etc. For example, when ice is heated, it melts to from water. When water is further heated, it boils to give stem. In this entry processes, only the physical state of water change where its chemical composition remain the same. The chemical properties depend upon the composition of the substance. When a substance undergoes a chemical change, its composition changes and a new substance are formed. For example, decomposition of water is a chemical change in as it produces hydrogen and oxygen gases. All materials are either a substance or a mixture. So simply classification of the matter into different forms: matter, mixture, substance, mixture, homogeneous mixture, heterogeneous mixture, substance, elements, and compounds. Elements, compounds, and mixture. Elements. In the early ages, only nine elements: carbon, gold, silver, tin, mercury, lead, copper, iron, and sulfur were known. At that time, it was considered that elements were the substance that could not be broken down into simpler units by ordinary chemical processes. Until the end of 19th century, 63 elements had been discovered had been discovered. Now 118 elements have been discovered, out of which 92 are naturally occurring element. Modern definition of element is that it is a substance made up of same type of atom having same atomic number and cannot be decomposed into simple substance of by ordinary chemical means. It means that each element is made up of unique type of atoms that have very specific properties. Elements occur in nature in free or combined from all the naturally occurring elements found in the world have different percentage in the earth crust, ocean, and atmosphere. Show naturally occurrence in percentage by weight of some major element around us. It shows constant concentration of these major elements found in the three main system of every environment. Naturally occurrence by weight percent of some major elements. Earth crust, oxygen 47%, silicon 28%, aluminum 7.8%, oxygen 86%, hydrogen 11%, chlorine 1.8%, atmosphere nitrogen 78%, oxygen 21%, argon 0.9%. Element may be solid, liquid, or gaseous. Majority of the elements exist as solid. For example, sodium, copper, zinc, gold, etc. There are very few elements which occur in liquid state. For example, mercury and bromium, bromine. A few elements exist as gases. For example, nitrogen, oxygen, chlorine, and hydrogen. On the basis of their properties, elements are divided into metal, non-metal, and metallites. About 80% of the elements are metals. Elements are represented by symbols which are abbreviations for the name of element. A symbol is taken from the name of the element in English, Latin, Greek of German. If it is one letter, it will be capital as H for hydrogen, N for nitrogen, and C for carbon, etc. In case of two letter symbols, only first letter is capital. For example, Ca for calcium, Na for sodium, and Cl for chlorine. The unique property of an element is its valency. It is combining capacity of an element with other element. It depends upon the number of electrons in the outermost shell. In simple covalent compound, valency is the value of hydrogen is the number of hydrogen atoms which combine with one atom of that element of the or the number of bonds formed by one atom of that element. For example, in the following compound. The valency of chlorine, oxygen, nitrogen, and carbon is 1, 2, 3, and 4 respectively. In simple ionic compound, valency is the number of electrons gained or lost by an atom of an element or complete its octet. Elements having less than 4 electrons in their valence shell prefer to lose the electron to complete their octet. For example, atoms of Na, Mg, and Al have 1, 2, and 3 electrons in their valence shell respectively. They lose these electrons to have valency of 1, 2, and 3 respectively. On the other hand, complete their octet. For example, NO, nitrogen, oxygen, and chlorine have 5, 6, and 7 electrons in their valence shell. Respectively, they gain 3, 2, and 1 electron respectively to complete their octet. Hence, they show valency of 3, 2, and 1 respectively. A radical is a group of atoms that have same charge valencies of some common element, and radical are shown in table. Some elements are radical with their symbol and common valencies. Element radical. Sodium. So एलिमेंट रेडिकल और सिंबल. सोडियम का सिंबल है Na, पोटेशियम का K, सिल्वर का Ag, मैग्नीशियम का Mg, कैल्शियम का Ca, ब्राइन का Ba, जिंक का Zn, कॉपर Cu, मरकरी का Hg, आयरन का है Fe, एल्युमिनियम का Al, क्रोमियम का Cr, क्रोमियम अमोनियम NH प्लस, हाइड्रोनियम H3O प्लस, hydroxide OH minus, tandine Cn minus, sulfate HSO4 minus, bicarbonate HC O3 माइनस। हाइड्रोजन का सिंबल है H, क्लोरीन का Cl, ब्रोमियम का Br, आयोडीन का I, ऑक्सीजन का O, सल्फर का S, नाइट्रोजन का N, फास्फोरस का P, ब्रोन का B, आर्सेनिक का As, कार्बन का C, कार्बोनेट का CO3 और 2 माइनस है। सल्फेट का है SO4, सल्फेट SO, थाइसल्फेट S2O3, नाइट्राइड N3 माइनस, फॉस्फोर P4 3 माइनस। इनकी वैलेंसी है, सोडियम की है 1, पोटेशियम की भी है 1, सिल्वर 1, मैग्नीशियम 2, कैल्शियम 2, बरेनियम 2, जिंक 2, कॉपर 1 2, मर्करी 1 2, आयरन 2 3, अल्मोनियम 3, क्रोमियम 3, अमोनियम 1, हाइड्रोनियम 1, हाइड्रोक्साइड 1, कैंडाइन 1, सल्फेट 1, बायोकार्बोनेट 1, हाइड्रोजन 1, क्लोरीन 1, ब्रोमाइन 1, आयोडीन 1, ऑक्सीजन 2, सल्फर 2, नाइट्रोजन 3, फॉस्फोरस 3 5, बोरॉन 3, आर्सेनिक 3, कार्बन 4, कार्बोनेट 2, सल्फेट 2, सल्फेटिक सल्फाइड 2, थाइसल्फेट 2, नाइट्राइड 2 3, phosphate 3. Some elements show more than one valency. They have variable valency. For example, inferior sulfate FeSO4, the valence of iron is 2. Inferior sulfate fermium is modified to end in O for the low valency. Ferrous and to end in Ic for the higher valency. Ferric compound is a substance made up of two or more element chemically compound together in a fixed ratio by mass. As a result of this combination, element lose their own properties and produce new substance. Compound that have entirely different properties. Compound cannot be broken down into its constituent element to simple physical method. For example, carbon dioxide is formed when element of carbon and oxygen combine chemically in a fixed ratio of by mass. Similarly, water is a compound formed by a chemical combination between hydrogen and oxygen is a fixed ratio of 1 colonial rate by mass. Compound can be classified as ionic or covalent. Ionic compounds do not exist in independent molecular form. They form a three-dimensional crystal lattice in which each ion is surrounded by oppositely charged ions. These oppositely charged ions attract each other very strongly. As a result of ionic compound have high melting and boiling point. These compounds are represented by formula unit. The covalent compound mostly exist in molecular form. A molecule is a trio respective of the covalent compound and its formula is called molecular formula. Mixture: when two or more element or compound mix up physically without any fixed ratio, they form a mixture. On mixing up the component substance, they retain their own chemical identities and properties. The mixture can be separated into parent component by physical methods such as distillation, filtration, evaporation, crystallization, or magnetization. Mixture that have uniform composition throughout are called homogeneous mixture. For example, air, gasoline, ice cream. Whereas heterogeneous mixture are those in which composition is not uniform throughout. For example, soil, rock, and wood. Difference between a compound and a mixture. Compound, it is formed by a chemical combination of atoms of element. Mixture is formed by the simple mixing up of substance. The constituents lose their identity and form a new substance having entirely different properties from them. Mixtures show the properties of the constituents. Compound always have fixed composition by mass. Mixture do not have fixed composition by mass. The component cannot be separated by physical means. The component can be separated by a simple physical method. Every compound is represented by a chemical formula. It consists of two or more component and does not have any chemical formula. Composition of homogeneous composition. They may be homogeneous or heterogeneous composition. Compound have sharp and fixed melting point. Mixture do not have sharp and fixed melting point. Atomic number and mass number. Atomic number. The atomic number of an element is equal to the number of protons present in the nucleus of its atom. It is represented by symbol Z. As all the atoms of an element have the same number of protons in their nuclei, they have the same atomic number. Hence, each element has a specific atomic number termed as its identification number. For example, all hydrogen atoms have one proton, their atomic number is Z is equal 1. All atoms carbon have 6 protons, their atom number is Z is equal 6. Similarly, in oxygen, all atoms have 8 protons, having atomic number Z is equal 8, and sulfur having 16 proton shows atomic number that equal है 16 के. The mass number is the sum of number of proton and neutron present in the nucleus of an atom. It is represented by symbol A. It is calculated as A is equal to Z plus N, where N is the number of neutrons. Each proton and neutron has a IAMU mass. For example, hydrogen atom has one proton and no neutron in its nucleus. Its mass number A is equal 1 plus 0 equal 1 atom. Carbon atom has 6 proton and 6 neutron. Has its mass number is equal to atomic number and mass number of a few elements are given in table. Relative atomic mass and atomic mass unit. As we know that the mass of an atom is too small to be determined practically, however, certain instruments enable us to determine the ratio of the atomic masses of various elements to that of carbon-12 atoms. The ratio is known as the relative atomic mass of the element. The relative atomic mass of an element is the average mass of the atoms of that element as compared to 112. The mass of an atom of carbon-12 isotope, an element having different mass number but same atomic number based on carbon-12 standard. The mass of an atom of carbon is 12 units and 1/12 of its comes to be 1 unit when we compare atomic masses of the element with the atomic mass of carbon-12 atoms. They are expressed as relative atomic masses of those elements. The unit for relative atomic mass is called atomic mass unit with symbol AMU. One atomic mass. Relative atomic mass is one atomic mass unit is 1/12 the mass of one atom of carbon. When this atom's mass unit is expressed in gram, it is 1 AMU is equal to 1.66 multiplied 10 raised to the power minus 24 gram. How to write a chemical formula? Compound are represented by chemical formula as element are represented by symbol chemical formula, and compound are writing keeping the following setup in consideration. Step number 1 is symbols of two elements are written side by side in the order of positive ion first and negative ion later. Step number 2 has the valency of each ion is written on the right top corner of its symbol. Step number 3 has the valency of each ion is brought to the lower right corner of other ion by cross exchange method. Step number 4, if the valencies are same, they are offset and are not written in the chemical formula, but if they are different, they are indicated as such as the same position. For example, in case of sodium chloride, both the valencies offset and formula is written as NaCl, whereas calcium chloride is represented by formula CaCl2. Step number five, if an ion is a combination of two or more atoms, which is called radical, being having a net charge on it, for example, sulfate and phosphate, then the net charge represents the valency of the radical. The chemical formula of such compound is written as explained in 3 and 5, writing the negative radical within the parentheses. For example, chemical formula of aluminum sulfate is written as Al2 bracket parentheses SO4 paras- parentheses 3, and that of calcium phosphorus S. Empirical formula. Chemical formula are of two types. The simplest type of formula is empirical formula. It is the simplest whole number ratio of atoms present in a compound. The empirical formula of a compound is determined by knowing the percentage composition of a compound. Here we will explain with it with simple examples. The covalent compound silica sand has simplest ratio of silicon and oxygen respectively. Therefore, its empirical formula is similarly glucose has simple ratio of carbon, hydrogen and oxygen respectively. Hence, its empirical formula is CH2O. As discussed earlier, the ionic compound exists in their dimensional network form. Each ion is surrounded by oppositely charged ions in such a way to form elastically neutral compound. Therefore, the simplest unit taken as respective of an ionic compound is called formula unit. It is defined as the simplest whole number ratio of mass has percent in the form in the ionic compound. In other words, ionic compounds have only empirical formula. For example, formula unit of common salt consists of one Na and one Cl ion, and its empirical formula is NaCl. Similarly, formula unit of potassium bromide is KBr, which is also its empirical formula. Molecular formula. Molecules are formed by the combination of atoms. These molecules are respected by molecular formula of benzene is C6H6, which is derived from the empirical formula CH, where the value of Na6. The molecular formula of a compound may be same or a multiply of the empirical formula. A few compounds having different empirical and molecular formula are shown in table. Compound hydrogen peroxide empirical formula HO, molecular formula H2O2, benzene C6H6, glucose empirical formula CH2O, molecular formula C6H12O6. Some compounds may be same empirical and molecular formula water H2O, hydroxide acid HCl, etc. Molecular mass and formula. Mass, the sum of atomic masses of all the atoms present in one molecule of a molecular substance in its molecular mass. For example, molecular mass of chlorine Cl2 is 71.0 AMU of water H2O is 10 U, and that of carbon oxide CO2 is 44 AMU. Some ionic compound that form their three-dimensional solid crystal are represented by their formula units. Formula mass in such cases is the sum of atomic mass or masses of all the atoms present in one formula unit of a substance. For example, formula mass of sodium chloride is 78.5 AMU, and that of CaCO3 is 100 AMU. Chemical species: ions, cations, and anions, molecular ions, and free radicals. Ion is an atom or group of atoms having a charge on it. The charge may be a positive or negative. There are two types of ions, cations and anions. An atom or group of atoms having positive charge on it is called cation. The cations are formed when atoms lose electrons from their outermost shell. For example, Na plus, K plus are cations. The following equations show the formation of cations from atoms. An atom or a group of atoms that has a negative charge on it is called anion. Anion is formed by the gain or addition of electron of an atom. For example, Cl minus and O2 minus. Following examples show the formation of an ion of addition of electron to an atom. Difference between atom and ion. Atom, it is the smallest particle of an element. Ion, it is the smallest unit of an ionic compound. Atom, it can or cannot exist independently and can take part in a chemical reaction. Ion, it cannot exist independently and is surrounded by oppositely charged ions. Atom, it is electrically neutral. Ion, it has a net charge either negative or positive on it. Molecular ion, when a molecule loses or gains an electron, it forms a molecular ion. Hence, molecular ion or radical is a species having positive or negative charge on it. Other other ions, they can be cationic molecular ions if they carry positive charge on amon ionic molecular ions. If they carry negative charge, cationic molecular ions are more abundant than ionic molecular ions. For example, CH4 HEN2. When gases are bombarded with high energy electrons in a discharge tube, the ionize to give molecular ions. Table 1.8 shows some difference between molecules and molecular ions. Difference between molecules and molecular ions. It is the smallest particle of an element or compound which can exist independently and show all the properties of that compound. Molecular ion, it is formed by gain or loss of electron by a molecules. It is a always neutral negative molecular ion. It can have negative or positive charge. Molecules, it is formed by the combination of atoms. Molecular ion, it is formed by the ionization of a molecules. It is a stable unit. Molecular ion, it is a reactive species. Free radical. Free radical are atoms or group of atoms possessing odd number of unpaired electron. It is represented by putting a dot over the symbol of an element. For example, free radicals are generated by the cumulative equal breakage of the bond between two atoms when they absorb heat of light energy. A free radical is externally reactive species as it has a tendency to complete its octet. Table 1.9 show some of the difference between ions and free radicals. Difference between ions and free radical. Ions, these are the atoms which bear some charge. Free radical, these are the atoms have odd number of electron. Ions, they exist in solution or in crystalline. Free radical, they can exist in solution as well as in air. Ions, their formation is not affected by the presence of light. Free radical, they may form in the presence of light. Types of molecules. A molecule is formed by the chemical combination of atoms. It is the smallest unit of a substance. It shows all the properties of the substance and can exist independently. There are different types of molecules depending upon the number and types of atoms. Combining a few types are discussed here. A molecule consisting of only one atom is called monatomic molecules. For example, the gases helium, neon, and argon are exist independently in atomic form and they are called monatomic molecules. If a molecule consists of two atoms, it is called diatomic molecules. For example, hydrogen H2, oxygen O2, chlorine Cl2, and hydrogen chloride HCl. If it consists of three atoms, it is if con, if it consists of three atoms, it is called triatomic molecule. For example, H2O, and CO2. If a molecule consists of many atoms, it is called polyatomic molecule. For example, methane, sulfate acid, sulfuric acid, and glucose. A molecule containing same type of atoms is called homatomic molecules. For example, hydrogen, ozone, sulfur, and phosphorus are the example of molecules formed by the same type of atom. When a molecule consists of a different kinds of atom, it is called heteroatomic molecules. For example, C CO2, H2O, and NH3. Gram atomic mass. Gram atomic mass is gram molecular mass and gram formula mass. Avogadro number and mole. Gram atomic mass is gram molecular mass and gram formula mass. पेज नंबर 17 मिस है तो वो इसलिए पेज नंबर 17 मिस है तो इसलिए पेज नंबर 18 करेंगे. Avogadro number and mole. Avogadro number. In chemistry, we deal with substances which are composed of atoms, molecules, or formula units. The containing of these particles is not possible for the chemist. The concept of Avogadro number facilitates the containing of particles. Contained in the given mass of a substance. Avogadro number is a collection of 6.02 multiplied 10 to the power 23 particles. It is represented by a symbol Na. Hence, the 6.02 multiplied 10 to the power 23 at number of atoms, molecules, or formula units is called Avogadro number. That is equivalent to 1 mole of respective substance. In the simple word, 6.02 multiplied 10 to the power 23 to understand the relationship between the Avogadro number and the mole of a substance. Let us consider a few examples. 6.02 multiplied times 10 to the power 23 atoms of carbon are equivalent to 1 mole of carbon. 6.02 multiplied 10 to the power 23 molecules of H2O are equivalent to 1 mole of water. 6.02 multiplied 10 to the power 23 formula units of NaCl are equivalent to 1 mole of sodium chloride. Thus, 6.02 multiplied 10 to the power 23 atoms of elements or 6.02 multiplied 10 to the power 23 molecules of molecular substance for 6.02 multiplied 10 to the power 23 formula units of ionic compound are equivalent to 1 mole. For further explanation about number of atoms in molecular compound or number of ionic ions or in ionic compound, let us discuss two examples. One molecule of water is made up of two atoms of hydrogen and one atom of oxygen. Hence, 2 multiply 6.02 multiply 10 to the power 23 atoms of hydrogen and 6.02 multiply 10 to the power 23 atoms of oxygen constitutes 1 mole of water. One formula unit of sodium chloride consists of one sodium ion and one chloride ion. So there are 6.02 multiplied 10 to the power 23 number of Na plus ions and 6.02 multiplied 10 to the power 23 Cl minus ions in 1 mole of sodium chloride. Thus, the total number of ions in 1 mole of NaCl is 12.04 multiplied 10 to the power 23 or 1.204 multiplied 10 to the power 24 mole chemist secret unit. A mole is defined as the amount mass of a substance that contains 6.02 multiplied 10 to the power 23 number of a particles, atoms, molecules, or formula unit. It establishes a link between mass of a substance and number of particles as shown in summary of molar calculation. It is abbreviated as mole. You know that a substance may be an element or compound. Molecular or ion mass of a substance is either one of the following: atomic masses, molecular mass, or formula mass. These masses are expressed in atomic mass unit with AMU, atomic mass unit AMU, but when these masses are expressed in gram, they are called as molar mass. Scientists have agreed that Avogadro number of particles are present in 1 molar mass of a substance. Thus, quantitative definition of mole is atomic mass. Molecular mass or formula mass of a substance expressed in gram is called mole. For example, atomic masses of a carbon 12 gram is equal 1 mole of carbon, molar mass of H2O expressed as 18 gram, 1 mole of water, molecular mass of H2SO4 expressed as 98 gram, 1 mole of H2SO4, formula mass of NaCl expressed as 78.5 mole of 1 mole of NaCl. Thus, the relationship between mole and mass can be expressed as number of mole non now mass of a substance divided by molar mass of the substance, mass of a substance, gram, number of moles, at molar mass. A detailed relationship between a substance and a mole through molar mass and number of particles is presented here. Summary showing a relationship between a substance and a mole. Chemical calculation. In chemical calculation, we calculate number of moles and number of particles of a given mass of a substance or vice versa. These calculations are based upon mole concept. Let us have a few examples of this calculation collecting the number of moles and number of particles from known mass of a substance. First, calculated the numbers of moles from given mass by using equation number of moles, no mass of substance, molar mass of the substance. Then calculated number of particles from the calculated number of moles with the help of following equation number of particles equal number of moles. You multiply 6.02 multiply 10 raised to the power 23. Mole mass calculation. In this calculation, we calculate the number of moles of a substance from the non-mass of the substance with the help of following equation. Number of moles, no mass of a substance, molar mass of the substance arrange when we rearrange the equation the to calculate mass of a substance from the number of a mole substance, we get mass of a substance G, number of moles multiply molar mass G. Mole particle equation calculations. In these calculations, we can calculate the number of moles of a substance from the given number of particles. These particles are the atoms, molecules, or formula units. So number of moles. Given number of particles Avogadro equal है given number of particles Avogadro की जगह आ जाएगा 6.0 Avogadro की वैल्यू आएगी 6.02 multiply 10 की power 23 on rearranging above equation we get number of particles number of moles multiply 6.02 multiply 10 raised to power 23.